Welcome to Primate Pro. This is a very good evening, and today we will start from the transport of the gases. This is the lecture number 5, and today we will continue with the transport of the gases and the oxygen dissociation curve. So let's start with the transport of gases. Okay. So in transport of the gases, we write blood. Blood has two components: plasma, which is liquid. Plasma is liquid, and another component is formed element. Okay. Now formed element, it's blood cell, blood platelets. Okay, blood cell and blood platelets. The blood cell consists of RBC and WBC. Okay, now RBC has hemoglobin. So in hemoglobin, the heme portion consists of iron, and the globin consists of protein. Iron and protein. Okay. So one hemoglobin consists of one heme and two, here's the globin. Okay, it's the iron part, and this is protein polypeptide. Okay, now we come to the next part as hemoglobin. Hemoglobin has two alpha chain and two beta chain. The two alpha chain and the two beta chain. Okay, now globin, basically the globin made up of four protein chain. In four protein chain, I have said already two alpha and two beta chain. Okay, so heme has iron component. Heme has iron component. Iron, that is Fe2 plus component, plus 2. So 4 hemoglobin, 4 heme consists of 4 Fe2 plus component. Okay, now we come to as plasma. So what is plasma? Oxygen dissolved in plasma. The RBC carries oxygen as well as the plasma also carries oxygen. So in alveoli contains oxygen. Okay, this oxygen is divided into two parts: dissolved in plasma it is 3% oxyhemoglobin. This is called HbO2 is called oxyhemoglobin. Oxygen binds with hemoglobin and form oxyhemoglobin. Okay, this is 97%. Okay, this is the RBC. Okay, now Okay, now when we come to oxygen. So oxygen here, oxygen binds to heme part of Hb, heme part of hemoglobin binds to Fe2 plus part, binds to the iron part. So oxygen binds to the iron part. So in case of ammoniatic patients, we find oxygen deficiency also, because the oxygen binds to the iron part of the hemoglobin. Okay, if the iron part is getting deficient, that means the oxygen carrying capacity of that person is going down. So we need to treat the anemia first. Okay, so one hemoglobin can carry 4 oxygen. Okay, now every 100 ml has 15 gram of hemoglobin. So 12 gram minus 16 gram. So 1 gram of hemoglobin can carry 1.34 ml of oxygen. 1.34 ml of oxygen. 1 gram of hemoglobin can carry 1.34 ml of oxygen. Now for every 100 ml of O2 blood, 15 into 1.34 ml O2, 15 into 1.34 ml O2. So therefore for every 100 ml O2 blood is equal to 20 ml O2. So hemoglobin equals to, write it down, hemoglobin equals to 4 heme, that is 4 iron particle. Take it as a note. Hemoglobin equals to 4 heme, that is the 4 iron particle. Now comes to the oxygen dissociation curve. This is very much important graph. This is a very much important graph in your NEET as well as in your MBBS life, because when you go to an emergency, if an ER patient comes, when you put on the leads, that is the monitor over the bed of an emergency patient, you will first get the ECG. When you put the ECG graph, 12 lead ECG graph, you will get the ECG lead. In the right side, it is shown as the heartbeat, that is the beat rates per minute. Later on that, it is shown as the respiratory rate. You will get the respiratory rate as well as the respiratory graph. The respiratory graph is shown in the left side, and then the right side the respiratory rate. Now the normal respiration rate of an human is 12 to 16 respiration per minute. Okay, and the normal rate of heart is 70 to 110 beats per minute. We can take it as normal. Okay, after that or slightly low or below, we consider it as normal with respect to the age, conditions of the patient, any comorbidities, etc, etc. So let us study about the oxygen dissociation curve and let us understand it very easily. Okay, now comes to the oxygen dissociation curve. Oxygen dissociation curve. Oxygen dissociation curve. A graph is plotted between partial pressure of oxygen PO2, that is PO2, and between saturation of hemoglobin with O2. Okay, Now I am drawing this graph. I need the scale. Okay, let it be this graph. Let me write this first. This helps. I'm drawing this graph. Please let me write this. This helps in understanding the binding of O2 with hemoglobin at various conditions and other factor like PCO2, H plus, temperature affecting the same. As P oxygen increases, the saturation of percentage saturation of the hemoglobin also increased. Okay. So I am drawing the graph here. Okay. Good. Now okay, now if we draw a graph, what is it is plotted against the percentage saturation of hemoglobin. The percentage saturation of hemoglobin here, the percentage saturation of hemoglobin with O2, percentage saturation of hemoglobin with O2, and here the PO2, pressure of O2. Now we draw the graph. This comes to be as sigmoid. Okay, now here also line has to be drawn. Okay, now the graph is like a sigmoid curve. The graph is like a sigmoid curve. Okay, this is a sigmoid curve. We see the sigmoid curve of the patient. Okay, now I will teach how to read this graph. Here 97% to 99.8% saturation. Here 75% saturation. Here 25% saturation. When the saturation of the patient drops below 65 to 60%, we generally intubate the patient. Intubate the patient means the patient is kept under ventilation. Because if you do not intubate the patient, we have to secure the airway first. The airway must be secured first, or else the patient will start to aspirate. Aspirate means the things will come out of the fluids will come and fluids will get choked in the airway. Okay, we need to secure the airway, and we to secure the airway we need to intubate the patient if the saturation falls below. In several diabetic ketoacidosis, metabolic disorders or respiratory disorders, we need to keep the patient under ventilation if the conditions goes critical. So there are several several requirements, eligibility to keep the patient under ventilation, because it is the last option to save the life of the patient, and in some cases it saves the life. Okay, the sigmoid curve, it is S-shaped. This is 25, this is 40, this called be as 100, this is 10. Okay, now let us study about the graph. So what does this graph actually means? What is the meaning? Okay, now comes to the next word. At lungs, what happens at lungs? At lungs, okay, लंग्स में क्या होता है? Partial pressure of oxygen equals to 40, O2 rising, okay, PO2 equals to 104, alveoli. Okay, then now the lungs, association of hemoglobin with oxygen. So what happens here? Partial pressure of oxygen is let me write with different color so that it will get okay. At lungs, the partial pressure of oxygen is high, the partial pressure of CO2 is low. So as the partial pressure of CO2 is low, the hydrogen ion concentration is low, so pH is high. The actual pH of the patient must be between 7.34 to 7.4. It is the ideal pH of the blood, and this has to be maintained at every time. If it is not maintaining, we must need to take action, because it is either going acidosis or alkalosis. We cannot change the pH of the patient and keep them untreated. It has to be treated with medical emergency. Okay, and the temperature is low. Where the temperature is low? At the tissues, opposite happens. At the tissues, what happens at the tissues? At the tissues, oxygen concentration is low, carbon dioxide concentration is high, H plus concentration is high, so the temperature high. Okay, therefore the pH is low at the tissues and the pH is high at the lungs. Okay, now take it a note, very important, the binding of oxygen with hemoglobin is primarily related to the partial pressure of oxygen, and other factors like CO2, H plus, temperature can also be affected, can also affect, let's write it, affect, can also affect this binding. Can also affect this binding. Okay, so what we have written, binding of oxygen with hemoglobin. ऑक्सीजन का हीमोग्लोबिन के साथ जो बाइंडिंग हो रहा है ये कैसे होता है, इज प्राइमरीली रिलेटेड टू द पार्शियल प्रेशर ऑफ, प्राइमरी रिलेटेड विद द पार्शियल प्रेशर ऑफ ऑक्सीजन. ऑक्सीजन का पार्शियल प्रेशर के साथ प्राइमरीली इसका संबंध होता है. ठीक है. अदर फैक्टर्स लाइक कार्बन डाइऑक्साइड, H+ टेम्परेचर ऑल्सो टेक्स also affects the binding process, because if the temperature is raised, so oxygen will bind less. Okay, if the H+ is high, oxygen will bind less. So in case of acidosis, the pH is lowered, and in case of alkalosis the pH is higher. If the pH goes higher, so what happens, the oxygen will bind less with the hemoglobin. So we can find the lactate curve in the ABG, that is the arterial blood gas. If we test the arterial blood gas of the patient and if we monitor the ABG of the patient, then we can see that the lactate curve is gradually increasing. The lactate curve is increasing, that means the oxygen is not perfectly binding in the lungs. So we need furthermore medical intervention. Okay, these are basically the ICU ITU notes of the doctors. Okay, you will probably not get this right now. In MBBS, in general medicine, or in internship when you remain in the ward, and in biochemistry and physiology you will study, but in the real life you will see in your OPD cases, not ICU and ITU CCU cases. Okay, these are the basics of the medical emergency. And first we have to secure the respiratory airway of the patient. It has to be secured first. Okay. So now in case of 100 ml of blood, where the 100 ml of blood is coming, 100 ml of blood, 100 ml of O2 blood, 100 ml of O2 blood, this comes here. 100 ml of O2 blood, here 20 ml of oxygen. 100 ml of O2 blood contains 20 ml of oxygen. Okay, now here 5 ml of O2 is delivered to the tissues out of 20 ml of oxygen. Okay, this is the tissue. Okay, at normal level, at normal physiological condition, 15 ml of O2 in blood carries 15 ml of oxygen, and 5 ml of oxygen is delivered to the tissues. This is called the systemic capillary. Here in the systemic capillary, okay, it is a systemic vein. So this is all for today. Okay, in the next lecture I will make you teach about further more topics, and I will complete it in 1 to 2 lectures. This chapter will be completed. I am trying to make chapters like one day one chapter. It will be very much beneficial, be the lecture be of 1 hour or 1.5 hours, but it will be of one day one chapter, or 3 videos will come at a day to complete the chapter. Okay, 30 minutes का 3 video आएगा एक दिन. It will complete the whole chapter at a single day, because you don't have much time. The exam is approaching in May, so let's study hard and crack it. Okay, this is for now. Thank you.